to another video for Algebra 2. In this video, I'm responding to some questions that I got via email during break. And there's three questions in particular. One on page 185, number 54, page 195, number 24, and page 205, number 25. So let's go ahead and jump in. Page 185, number 54. So what it's asking to do here is that we solve for the roots. We find a solution of this equation. Let me write it out. Negative 7x plus 6 equals 20x squared. Okay, so we want to factor this out. And I want to put this in standard quadratic form. So that means I'm going to have to move this over to this side of the equation. So that's going to give me a negative 20x squared minus 7x plus 6 equals 0. So now I can use, I can use quadratic form, I can do completing the square, whatever the case may be, but it's asking me specifically to solve this by factoring out. Okay, and that's tricky because of two things. You're asking me this question, and I'm thinking there's probably two reasons why. Number one, there's a number that's greater than 1 and the leading coefficient, and you probably tried to divide that out, right? And you found out that you couldn't do that. It doesn't make a clean number on any of my terms. And so the next thing is that the next problem is that negative sign on the leading coefficient. That negative sign is a problem. So I want to get rid of both of those things. I want to get rid of both the negative sign and that 20. I know I can at least get rid of one right away, and that's the negative sign. So what I'm going to do is I'm going to factor out the negative sign out of this entire equation here. I'm going to factor a negative out on the outside. Okay, and that's going to give me a whole new equation. And I'm going to put that in brackets of, so when I do that, every one of these signs, let me highlight them, every one of these signs will become the opposite, right? Because I factored out the sign, so they will all be opposite of what they were originally. So 20x squared plus 7x minus 6, close parentheses, equals 0. Again, I'm using, this is still the same equation. I've just altered it for my purposes, but still the same equation. So the next thing that I see there is that I have a 20 there. That's a problem, and I can't. It's not very. Now I could divide the whole thing out by 20, but it's going to make it just. It's actually going to complicate things. Now there is another technique where you can take your a term times your c term, and that's going to be 20 times negative 6. That'll be negative 120. Okay, and I can use the factors. I need to find the factors of negative 120, and if I can find two factors that when I add them together will give me a positive 7, I can actually split that middle term into two different factors that will help me factor this whole thing out a lot easier. So then what I do, because now I'm looking for factors for negative 120, I just start from 1. So 1 times negative 120. Now 120 has to equal negative 120, so one of these terms will have to be negative. At this point it doesn't matter because when I add these together it's going to be 121, right? So that's 121. So that's nowhere near the 7, or the difference between 120 and 1 is 119. Sorry, that's the way I should really be thinking it, and that's nowhere near 7. So 2 times 60 is negative 120. It can be negative 120, depending on, either one can be a negative. And the difference between 2 and 60 is 58. So that's closer, right? And because actually my middle term is a positive number, so that I know that my small number is going to have to be a negative 1, right? Because that'll be 19 and that'll be 58. So now let's go to the next term, 3. Negative 3 times what number? 40. Will equal negative 120. So negative 3, the difference between negative 3 and 40 is 37. Okay, how about 4? Negative 4, and what's that? It's going to be 30, right? That's going to be negative 120, and the difference between those two is 26. So you'll notice that I'm getting closer, right? I'm getting closer to 7. So if I keep going down 1, 2, 3, 4, 5, 6, 7, I'm going to find that negative 8 times 15 is negative 120, because I'll do 5, 6, and I'll do the same thing for 5, 6, and 7. But when I get down to negative 8 times 15 is negative 120, I find that the difference between negative 8 and 15 is in fact 7, which is what I am looking for here. So I can actually use these two terms now. I can make 7 into these two terms. Now see what happens here. This is kind of subtle and it's a little tricky, but it works. So I have 20x squared plus 15x minus 8x minus 6, close parentheses. Okay, so what I can do is I can actually group these separately. Okay, I can group these separately and work with each of these individually. So with this particular first group right here, okay, I'm going to do my bracket. I can look at the common factors, and it's 5 and x, so I can factor out of 5x, and this will be to 5x times what will give me 20x squared. It's going to be 4x plus, and then what times 5x will give me 15x, and that's 3. Okay, so notice, it may not be obvious, but notice that this is the same thing as this. I have factored it out, and remember that is what my goal is to factor out that whole thing. So now I'm looking at my next set. I'm going to highlight it in green. I'm looking at this, negative 8x minus 6. So what can I factor out? First thing I can factor out is the negative sign, the minus. And what do 8 and 6 have in common? A 2. So that's 2. And so now what will I have left inside? So negative 2 times what will give me negative 8x? That's a 4x. And then negative 2 times what will give me a negative 6? That's a plus 3. So negative 2 times positive 3 is negative 6, right? So again, notice that what I have in green is the same thing of what I have in green on my second term there. Okay, it's the same thing, it's just factored out. Okay, so now what I can do, notice, I'm going to highlight in blue, notice that I have a 4x plus 3 and a 4x plus 3. These are the exact same thing, and that's very helpful in my next step, because I can group the 5x and the negative 2 together, giving me negative brackets, giving me a 5x minus 2 times a 4x plus 3, close. And if I were to factor, if I were to FOIL everything in here, I would in fact end up with the same thing I have right here. Same thing. It's the exact same equation. It doesn't look like it. It's the exact same equation. All I've done is factored it out. So it looks different, but it's exactly the same thing. Okay? Now, at this point, I've done a lot of factoring. At this point, I want to remember what my original goal was. And if I go back to the question was to find the zeros. Find the zeros using the factoring technique. So that means to find the zeros, I need to find out what's going to make this 0 and what's going to make this a 0, right? So 5x minus 2, what's it going to take to make that 0? And then 4x plus 3 equals 0. Now at first glance, this may not seem like something we've done before, but it actually is. It's just a more complicated form of it. But go back into your notes, go back into problems that we've done previously, and you'll notice, and remember, I don't know if I mentioned this or not, but I'm referencing problems from on page 182 in your textbook. So you can go back to that as a reference to what we've done as far as factoring out problems. So going back to this problem now, so I'm looking at 5x minus 2, and I want to find what x needs to be for this whole thing to become 0. So I'm going to add 2 to both sides. I'm left with 5x equals 2. And then divide by 5 on both sides, and I have x equals 2 over 5. And that is my first 0. Now I'm looking at 4x plus 3. So minus 3 to both sides. 4x equals negative 3. X equals negative 3 over 4. and there is my other 0. So recall, when I'm talking about finding zeros or finding the roots of problems, all I am doing, so this is 1, this is a coordinate plane. All I am doing is finding where my my parabola crosses the x-axis, right? And is this an open circle? Does this open up or down? It's a negative. This is a negative leading coefficient, so that means that it opens down, right? Something like that. It's not exactly it, but something like that. Okay, so that's that one. So again, I am solving this equation. I'm finding the roots by factoring. Now I could have easily used quadratic formula too. Okay. In fact, to check yourself, you go ahead and solve this using quadratic formula, and you'll find that you'll get the exact same answer. Okay, but I'll let you do that on your own. So I'm going to go ahead and move over to the next problem. That's page 195, number 24. Okay. So with this particular problem, it's asking me to use square root property, okay? And I have to find it to the nearest 100th. Nearest 100th. Okay? It's just I'm writing it down so I don't forget. So what's my problem? X squared plus 7x plus 49 over 4 equals 4. Okay? So the square root property. So that means I'm going to have a square root somewhere in here. But the first thing I need to do is I need to factor this out. Is this a perfect square? One of the things that I'm noticing here is that 49 is a perfect square, and so is 4. Okay, that can be 7 2 squared, right? Because 7 squared is 49, 2 squared is 4. So what that leads me to believe is that this whole thing here, I can actually go ahead and I don't have to do completing the square, because this will actually end up being this. So this here equals this, and I'll prove it to you. Let's go ahead and work it out. So x plus 7 over 2 times x plus 7 over 2, right? So I'm going to do FOIL, right? This term into the first, and then that term. That leaves me with x squared plus 7 over 2x, right? And then I'm going to do the same thing with the second term, same thing, and I end up with 7 over 2x plus 7 over 2 times 7 over 2, that's 49 over 2. And this right here in the middle terms, 7 over 2, that's basically 3.5, right? 3.5 plus 3.5 is 7x plus 49 over 2, which is exactly what I had in the very beginning, right? Okay, so now that you're satisfied with that, and you can see that it does equal that, okay, and it's always nice to double check yourself just to make sure. Let me rewrite that here. So I have x plus 7 over 2 squared equals 4. So it asked me to use the square root property. So like I said before, that means I'm going to have to use the square root somewhere in this, and here it is. I need to get rid of that squared, and the only way to do that is to square root. So I end up with a new equation so that cancels out there, so I end up with x plus 7 over 2 equals plus minus square root of 4. Okay, so x plus 7 over 2 equals plus minus 2. Now one thing that I want to remind us of is that it's asking me to find to the nearest hundredth. And I have this in fraction. Hundredths is in decimal, so I can go ahead and just convert that to decimal. So that's x plus 3.5 equals plus minus 2. And I'm going to find out what x is, so I need to subtract by 3.5 on both sides. So this gives me x equals negative 3.5 plus minus 2. Right? So I have x equals negative 3.5 plus 2, and x equals negative 3.5 minus 2. And this one is x equals, that's a negative 1.5, so there's one of my zeros. And then my second one is x equals negative 3.5 minus 2 is minus 5.5. Let me get rid of this right there. And then here is my second answer. So these are my two zeros. So those are my two zeros using the square root property. Okay, now last but not least, I have page 205, number 25, and it's asking me for three things. The discriminant, and then when I find the discriminant, I will be able to tell what kind of roots I will have, and then I will confirm that by finding the exact roots using quadratic formula. So, to start off, I'm going to go ahead and write my formula, 3x squared minus 3x plus 8 equals 0. So it's already in the quadratic form, and then I'm going to write my quadratic formula. X equals negative b plus minus square root of b squared minus 4ac all over 2 times a. And then I remind myself that my discriminant is what's underneath the square root sign. So that's what a is, so that's what I want to find out first. Right? So my b is negative 3 squared minus 4 times a, which is 3, times c, which is 8. And then I want to find out what this is. So negative 3 squared is 9 minus, what is this, 96? So that gives me a negative 87. All right, so this is interesting because I have a negative number, I have a negative 87. So that's the first, so that's part A. I've just solved part A. So I've got that part of the problem solved. Now the next thing I notice is that this is a negative number underneath the square root sign. And recall that I do not want negative numbers underneath my square root sign. Okay? Because whenever I have a negative number under my square root sign, you know I'm going to have to factor out that negative 1. And recall that negative 1, the square root of negative 1 equals I. And that's a complex number. So that means I'm going to have two complex roots. So then my roots will be, I will have two, it says, for part B it says, what types of roots will I have? I will have two complex roots. And again, I was able to figure that out because I have a negative number. I have a negative number in my square root. So there's part B. So now what I want to do is I want to confirm that, right? I want to confirm that I actually do have two complex square roots. So let's work this out. So x equals negative b. So the opposite of negative 3 is positive 3. So that's 3 plus minus. And then I already know what my discriminant is. That's a negative 87, right? Divided by 2 times a, which is 2 times 3, is 6. All right. So 3 plus minus, and I have a negative number. So I have a negative 87. I want to factor out that negative number, so it's going to be a square root of negative 1 times the square root of 87, all divided by 6. And recall that the square root of negative 1, like I mentioned earlier, is in fact I. So then I will have 3 plus minus I times the square root of 87, all divided by 6. So I can spend the next 10 minutes going over all the different factors of 87 to see if I can in fact break it up into something that would be a perfect square. The closest thing that I found off recording here was the square root of 29, what was that? I think that's going to be 3 times the square root of 3. But neither one of these numbers is a perfect square. And in fact, I did not find any number that will give me, I can break up 87 to give me a perfect square root to clean this up a bit. So this is, in fact, this is actually as far as I can go with this particular solution. Now, again, you know, just at initial glance, this may not look like an answer, but you know, as you're working these out, if you can't find, if you find that you can't break up that square root, then that in fact is your answer right there. I can't simplify this term anymore. I cannot simplify this any more than it already is. So that is an answer. So I'm guessing maybe you worked this out and you got to this point and you said, well, why, this should be a little bit cleaner, but that's actually good. If you got to this point, then you're actually okay. Not all answers are going to be nice, clean, single digit, whole numbers or whatever. Some of them are going to be like this, and that's okay. So that does it for this. That was page 205, number 25. So I hope that this little session helped, and I want to wish you good luck in your studying.